Hi students, welcome to today's class. Today onwards, from 26th onwards, your JEE mains exams are going to be commence, and for that examinations, so today onwards will take the miscellaneous problems, different chapters, different important models I will take. Okay na? So all type of variety of problems I will cover in these videos. Okay, so without wasting your valuable time, so let us start our class. Okay, so the first question is limit y tends to 0 under square root of 1 plus square root of 1 plus y to the power of 4 minus square root of root 2 by y to the power of 4. Okay, now right. Then what is the limit of this function? So options are exist and equals to 1 by 4 root 2, exist and equals to 1 by 2 root 2 into root 2 plus 1, exist and equals to 1 by 2 root 2, does not exist. So those are the options. So if you substitute y is equal to 0 here, so this is a 0 to the power of 0, 1 plus 0, 1 root 1, 1, root 2 minus root 2, 0, and you will get this as a 0 by 0 you will get. But if you start this problem using short trick method, that is a L hospital rule, it takes a long time to solve it. Why? Because here y to the power of 4 is there, 4y cube, 12y square, 24y, again you have to do, that means almost 4 times you have to do the differentiation. So how to proceed means, so multiplying the numerator and denominator with here minus is there with the plus quantity, that's all. Okay, now let us see this. So limit, the first problem, limit y tends to 0. So if you multiply the numerator denominator with the plus quantity, a square minus b square you will get, that is a 1 plus root of 1 plus y power 4 minus 2 by, so y to the power of 4 into root of 1 plus root of 1 power 4 plus root 2. Understand this? Okay, na? So this is equal to how much? Limit y tends to 0, root of y to the power of 4 minus 1 by y to the power of 4 into root of 1 plus root of 1 by whole power 4 plus root 2. Okay, na? Right. Again you multiply, here minus is there, no, plus quantity. So numerator and denominator. So that is a limit y tends to 0. So this is a y to the power of 4 minus 1 by y to the power of 4 into root of 1 plus root of 1 plus y to the power of 4 plus root 2 into root of 1 plus y to the power of 4 plus 1. This is the quantity. Okay. So any more cancellations? Yes, if you see here, plus 1 minus 1 cancel, y to the power of 4, y to the power of 4 is also cancel. So wherever y is there, substitute 0. So you substitute 0, what you will get? 1 by square root of. So if you substitute 0, 1 plus 0, 1, root 1, 1, 1 plus 1, 2 root 2 and the whole. So this is equal to 2 root 2 into 1, 1 plus 0, 1, root 1 into 1, 2. So this is equal to 1 by 4 root 2. Okay. So this is 1 by 4 root 2. Therefore, the limit exists. Here for this problem, no need to find out left hand side limit, right hand side limits. So here limit exists and it's equal to 1 by 4 root 2. Okay. I hope that very easy problem. I hope that you understand this solution. Let us go to next problem. Welcome to this problem. So this is from complex numbers. If 1 plus I by 1 minus I whole to the power of x is equal to 1, then what is the value of x? So here see the options. X is equal to 2n plus 1 where n is a positive integer, x is equal to 4n where n is a positive integer, x is equal to 2n where n is a positive integer, x is equal to 4n plus 1 where n is a positive integer. Then how to do that? So what value you have to substitute in place of x such that the answer should be 1, either even number or odd number. Okay, now that we have to know, right? Then how to do this problem? Okay, so we will do like this. So this is a 1 plus I by 1 minus I into, so here for a numerator and denominator, so multiply with 1 minus I by 1 plus I by 1 minus I whole power x is equal to 1. Understand? So here minus is there, no, plus. Okay. So this is equal to 1 plus I whole square by a plus b into a minus b, a square minus b square. A square means 1 minus I square means minus 1. 1 plus 1, 2. Whole power x is equal to 1. So, this is equal to a plus b whole square. This is equal to a square means I square. 1 square plus b square means I square minus 1 plus 2i by 2 whole power x is equal to 1. So, if any more cancellations, yes, cancellations is there. So, here plus 1 minus 1 you can cancel, 2 is also cancelled. I to the power of x is equal to 1. I to the power of x is equal to 1. So, here what should be the value of x? See here, the value of x should be I to the power of 4n is equal to 1. Therefore, where x is equal to 4n and belongs to an integer. Therefore, x is equal to 4n is the correct answer. Okay now, right. You may ask one doubt. So, sir, why can't we take 2n? Why can't we take 2n? Understand? See here, if you take I to the power of 2n is equal to 1, not always. For example, if you take n is equal to 1, n is equal to 1, he is saying n is a positive integer. That means I square value is minus 1. I square value is minus 1. Understand this? So, at this stage, generally definitely odd number cannot be. Odd number cannot be. So, option A and option D both will be wrong. In B and C, students will get confusion. So, if you take 2n, n is a positive integer. If you take n is equal to 1, I square value is minus 1. I square value is minus 1. From there onwards, it will satisfy. If from n, if n take n is equal to 2, n is equal to 3, n is equal to 4, okay. But if you take 2n, you won't get the answer. For n is equal to 1, it fails. That's why the perfect answer is 4n. Okay, x is equal to 4n. Okay. So, I hope that you understand this solution. Okay, let us move to next problem. Welcome to this problem. So, this is also from complex numbers. From complex numbers and binomial both together, the problem will be there. Let us see this. If z is equal to 2 plus 3i, then z to the power of 5 plus z conjugate whole to the power of 5 is equal to. So, this is given in 2022. Such an easy problem. Almost everybody will do this problem. Okay, let us see how to do this problem. Yes. We know if z is equal to 2 plus 3i, then its conjugate is equal to 2 minus 3i. So, therefore, z to the power of 5 plus z conjugate whole to the power of 5 means this is a 2 plus 3i whole to the power of 5 plus 2 minus 3i whole to the power of 5. 2 plus 3. So, this is equal to, already we know the expansion of a plus b whole to the power of 5 plus a minus b whole to the power of 5 expansion. So, this is equal to 2 times 5c0 a to the power of 5 plus 5c2 a to cube into b square plus 5c4, that's all that will come. Okay, even suffixes will come. So, the same concept applies here. That is equal to 2 times 5c0 into 2 to the power of full plus 5c2 into 2 cube into 3i whole square plus last one 5c4 into 2 to the power of 1 into 3i whole to the power of 4. 3i whole to the power of 4. Let us calculate this value. So, this is equal to 2 into 5c0 value is 1, 2 to the power of 5, 32. Plus, so here I square value is minus, so that's why minus I wrote. 5c2 value is a 10 into 2 cube 8, 3 square 9 plus 5c4 value is a 5 into 2 into I to the power of 4 value is 1. So, 3 to the power of 4, 3 3s are 9, 9 9s are 81. So, if you calculate this, all these things, so you will get 244. Okay, calculate. So, you will get the 244 will be the final answer. Okay, now. So, very easy problem. See here, this was asked in 2022 JEE mains examination for 4 marks. Okay, such type of problems are also giving. So, this is both complex numbers and binomial problem together, mixed problem. Okay, now, right. I hope that you understand this solution. So, let us move to next problem. Hi students, welcome to this problem. So, one of the somewhat carefully how to do. First thing, alpha greater than 0, beta greater than 0 be such that alpha cube plus beta square is equal to 4. The relation between alpha and beta is alpha cube plus beta square is equal to 4. Okay, put it like that. If the maximum value of the term independent of x in the binomial expansion of, so this is the binomial expansion, is 10k, then the value, then k is equal to. So, in this binomial expansion, there is a independent term, its maximum value. So, when alpha cube plus beta square is equal to 4, obeying that condition, its maximum value is 10k, then what is the value of k? Okay. First of all, let us find out what is the independent term in this binomial expansion. See the solution. If the independent term in this binomial expansion is a tr plus 1, so see here, alpha into x to the power of 1 by 9 plus beta by x to the power of 1 by 6 whole to the power of 10. Here x to the power of minus 1 by 6, I have wrote it as a 1 by x to the power of plus 1 by 6. In this binomial expansion, if independent term is a tr plus 1, if independent term is a tr plus 1, then r is given by 10 into 9, 10 into 1 by 9 by 1 by 9 plus 1 by 6. In this binomial expansion, if independent term is a tr plus 1, then r is given by the value 10 into this value, 1 by 9 into 1 by 9 plus 1 by 6. So, this is equal to 10 by 9 by, so here 9 will come, here 6 will come. So, this is equal to 15 by 9 into 6. So, this 9 will cancel. So, this is equal to 10 into 6 by 15. So, this is equal to 3 2s are 3 5s are 5 1s are 5 2s are, that is equal to 4. That means T5 fifth term is independent term. What is the independent term? T5. Let us find out T5 fifth term. So, no need to write down x and x values. So, here what is the T5 term? 10c4 into alpha to the power of 10 minus 4, 6 into beta to the power of 4. So, this is the independent term in this binomial expansion. Its value depends upon the alpha and beta value. So, this value depends upon the alpha and beta value. For this, there is a relation is given, alpha cube plus beta square is equal to 4. Using that relation, we have to find out the maximum value of alpha to the power of 6 into beta to the power of 4. Okay. So, if this value is equal to 10k, then we will find out the k value, no problem. Okay, right. Then let us continue our calculation. Welcome back to the remaining calculation part. Here, so this is the independent term given. So, alpha cube plus beta square is equal to 4 relation is given. So, let us see the solution. So, here alpha cube beta square, let us take these two quantities. We know that arithmetic mean is always greater than or equal to geometric mean. We will get a relation here. Why? Because here alpha cube plus beta square is there. Here something alpha into beta is there. So, if you want to get that type of relations, you have to make use of that. What is that arithmetic means? A plus b by 2 is greater than under square root of ab, geometric mean. Now, what is this arithmetic mean? So, this is a alpha cube plus beta square by 2 is greater than or equal to root of alpha cube into beta square. Okay, now alpha cube plus beta square value is equal to how much given? 4, 4 by 2, 2. 2 is greater than or equal to root of alpha cube into beta square. Squaring on both sides, 4 greater than or equal to, so this is equal to alpha cube into beta square. That means alpha cube into beta square is less than or equal to 4. Alpha cube into beta square less than or equal to 4. But we want alpha power 6 into beta to the power of 4. So, let us squaring on both sides. So, this is equal to alpha power 6 beta to the power of 4 less than or equal to 60. We want 10C4 into alpha power 6 into beta to the power. So multiply with the 10C4 into alpha power 6 into beta to the power 4 less than or equal to 10C4 into 16. So this value is less than or equal to 10C4 into 16. Therefore, what will be the maximum value here? This is the maximum value. So 10C4 into alpha power 6 into beta to the power of 4 is less than or equal to 10C4 into 16. Less than or equal to 10C4 into 16. Okay now? So this will be the maximum value. This maximum value is given, that is equal to 10K. This is equal to 10K. Okay now. Then what is the value of 10C4? So 10C4 value is equal to 10 into 9 into 8 into 7 by 7, 8, 9, 10. 1 into 2 into 3 into 4. Okay now? Into 16 is equal to 10K it is given. So I am rubbing here. It is given 10K. So calculate cancellations. So this is equal to 10, 10 cancel. So 2 4s are 8 cancel. 3 1s are 3 3s are cancel. Next 3 7s are 21. So 21 into 16. 336. Therefore, K is equal to 336. K is equal to how much? 336. Understand? So your K value should be 336. Okay, very nice problem. So we have used this concept. Arithmetic mean is greater than or equal to 0. So always remember that if you want to get a relation into, if two quantities into relation if you want to get, but plus relation is given. Here plus relation is given. If you want to get a into relation between those two quantities, use this concept arithmetic mean is greater than or equal to geometric mean. Okay na? Right. I hope that you understand this solution. So latest problem. Okay. So let us move to next problem. Hi students, welcome to this problem. See here, it is a very basic level problem. So this was asked in 2015 JEE mains examination. So let us see here, the solution is a limit x tends to 0. See here, x tends to 0. Cos 0 is equal to how much? Cos 0 is equal to 1. 3 plus 1, 4. Up to here very clear. The answer is 4. Okay now. 1 minus cos 2x. 1 minus cos 2x is equal to 2 sin square x by. So x into tan 4x. X into tan 4x. Its value is 4. Okay now, right. See here, I will do here by x, so that I will put x square here. Put x square. Okay now, right. Up to here, limit x tends to 0, sin square x by x square value is equal to how much? Its value 1. And limit x tends to 0, tan 4x by 4 value is equal to how much? 4. So on the whole, so this is equal to 2 into 1 into 4 by 4. 4 cancel 2. Option A is the correct answer. Okay, so very easy problem. This is almost everybody will do this type of problem. So this type of problems are also giving in the JEE mains examination. Okay, so let us see the one more problem. Hi students, welcome to this problem. So here it was given from the chapter sets. Very first chapter sets. Completely the question belongs to the chapter sets only. So this is the question in 2022, right? So here A is equal to 1, 2, 3, 4, 5, 6, 7. There is a set containing those elements, 7 elements. B is another set, 3, 6, 7, 9. Then the number of elements in the set. In this set, you have to find out the number of elements. So see the solution here. Here A is given, how much? A is given 1, 2, 3, 4, 5, 6, 7, and B is given 3, 6, 7, 9. Now, there is another set C. There is another set C. So, here 1, 2, 3, 4, 5, 6, 3, 6, 7, 9. So, these are all overlapping sets I am telling. So this is A and B, both are overlapping sets. Why? Because here 3, 6, 3, 6 is also there, overlapping sets. Now there is a set C subset of A. C subset are equal to A such that C intersection B is equal to null set. That means your C set is here. This is a C set. Understand? C is subset of A and C intersection B is null set. There is no common element. C is subset of A. C intersection B is null set. C intersection B is null set. Understand? It is not equal to pi. Sorry, it is not equal to pi means that means it is not a null set. That means like this it is there. So C intersection B should not be a null set. Should not be a null set. That means there should be some elements. There should be some elements. C intersection B is null set. So you have to you have to find out such a set. Such a the number of elements in such a set, that is called it as a S. You call it as a S is equal to, in the set, how many elements will be there. So you have to take those elements in that set, number of elements in the set, such that that is a subset of A and it is not a, should not be, C intersection B should not be null set. Okay, now let us see that. First of all, how many subsets are there? So number of subsets of A is equal to how much? 2 power n, that is a 1, 2, 3, 4, 5, 6, 7, 2 power 7. 2 power 7 is equal to how much? So this is equal to 2 power 7 means 2 power 32 into 4, 128. So this is equal to 128 subsets are there. First of all, C and B, they are not null sets. That means C should contain here 3, 6, 7, 8, no. So this 3 is there, 6 is there, 7 is also there, 1, 2, 4, 5 should be there. C is a set 1, 2, 4, 5. C intersection 1, 2, 4, 5. If C intersection B is there, if C intersection B is equal to null set, for example, if C intersection B is equal to null set, that means if it is a C, then C should contain the elements 1, 2, 4, 5. See here, 1, 2, 4, 5. So C intersection B is coded. But he is saying that C intersection B is not a null set. C intersection B is not a null set means what? Therefore, total number of elements in S, that means final set, is equal to total number of subsets of 128, that is equal to total number of subsets of A minus this subset. That means C intersection B is equal to null sets. No, if you subtract the number of subsets of this, that is equal to 2 to the power of 4. If you subtract 2 to the power of 4, that means C intersection B is equal to null set subsets you are subtracted, then you will get C intersection B is not equal to 5. Okay, now. So this is equal to 128 minus 2 to the power of 4 is 16. This is 112. So therefore, final answer is 112. Understand? I hope that you understand this solution, and tomorrow onwards I will explain all the miscellaneous problems. Miscellaneous problems means all chapters I will cover, from algebra and geometry and calculus. Almost all topics I will cover, and so I hope that you enjoyed today's class. With some more problems, tomorrow's class I will stand before you. Until then, all the best.